Anyway, the bus is not gonna leave from here because there is no place to stop. It's going from in front of Diplomat Hotel, so people from Czech know. But people who don't know, we will meet here at around 10 to 3, and we will take you to the bus. So 3:50, we will meet here. Yeah, here after the lunch. 2:50, yeah, 2:50, and we will go to the bus. The people that know, they can. We will just meet you there at the bus. The bus will leave at 3:15 sharp. So be on time, please.
And we will return around 6 to Prague, or here in Davice. In case you want to have some fun in the evening, just how to go to the hotel by public transport, just get somehow on line A of the underground, the green one. To stop, which is called Nádraží Veleslavín. And then take bus 225. It starts there, so you cannot take the wrong direction unless you really try to. And you go to Staré náměstí. And just be careful because your hotel is next to a big prison, so take the right door. The left door goes to the prison, but the right door goes to the hotel. And if you're joining the ladies' night,
I will meet you at the bus when you come from Líbeznice, and we will go directly. So that's, and tomorrow, if I'm not wrong, 8:30, I will pick you up at the hotel, and we will go by bus to Buštěhrad, to the meeting place.
And maybe one last thing. The tickets that I gave you are for 30 minutes. So it's enough to go from here to the hotel. But if you'll go from the city center, it's necessary to buy the more expensive ones, which are for 32 crowns. But there are the machines everywhere, and you can even use the credit card to buy the tickets. And use just one ticket. The second one. Wim, yes, the second one. Not the first one. If you have used the second one for the first ride, it's wrong. So we will slowly begin with our session. We are waiting for the connection. Again, apologies for the connection, but we realized that really it wasn't our fault, but entire YouTube was down in the morning, like worldwide. So thanks again to František for dealing with this issue. And we are waiting for the signal. We can start. Okay, so we have our last session before the lunch, which is called Practical Aspects of MPC Implementation. I'm not click to add subtitle, but I'm Lukáš Ferkl again. And I will guide you through this session. I will be joined shortly by Filip. Filip, where is Filip? Filip is ready. And Jirka, or Jiří, or Jiri. It depends on in which language you read his name. And we will have it organized as follow. We have 7 topics, and it will take us approximately 8 minutes per topic. So I will start with the first topic, and then will come the other ones. And we will have 1 or 2 slides introducing the topic, and then we will have a short discussion. So, someone has stolen our presenter, Wim. Do you have the presenter? Or who was the last one? Okay. Or I will, it's just 3 slides. So one of the tasks that we have in the project is a business model. So how to actually sell the hybrid geotabs concept for buildings, or the system, or the solution. And is it a system, or is it a solution, or is it a service? What it is. So here are some key values that that we want to deliver to the future customers of our system slash solution slash service. It's better system operation, lower investment cost, lower operating cost, better and stable indoor climate, better space utilization, and lower environmental impact. I may touch the lower investment cost. It of course depends on where you have the benchmark. So what we want to improve is the hybrid geotabs non-MPC system. Of course, if you have a very simple building with an electric boiler and fan coils, it's quite cheap. But if you want to save energy, you can have lower investment cost by proper sizing of the systems. So the modeling and the control allows you to use smaller technical systems, such as heat pumps or borehole fields, compared to the situation where you do not use the approach which is being developed within the project. What are our customers? We see that our primary focus group is or are the owners, investors, and operators of office buildings, schools, residential buildings, care homes, and so on and so forth. So with someone who has a long-term, non-speculative horizon, so someone who does not want a return of investment 5 years, 7 years, because this system does not have such a short return on investment. And what we realized that yeah, most of you here are architects or engineers, HVAC engineers, and or in other fields. So it's very important for us to spread the word and be sure that especially the engineers know the advantages of the MPC GT system or the hybrid geotab system, and that they are able to introduce those advantages to their customers in order to yeah, to benefit from the values that we want to deliver. So this was the first topic. So are there any questions concerning the first topic? Philip.
MPC Workshop, and my question is, what is the length of the return investments of this solution? The length of the return investment in the years. You said this is not for a long time, so
it depends on your benchmark, of course. But maybe Jiří can give the answer.
It's just my estimate, but what I heard is that these buildings are 20% more expensive, but the operational costs are much lower. So I think something. I'm calculating that, and I think something between 15 to 30 years. 15 to 30 years. Yes. So
it depends a bit again what is the case that you're comparing. If you're comparing the entire hybrid geotypes concept, then you need detailed cost data on that, which I don't have. But if we keep it to controls, for instance, so if you're comparing a rule-based controller with an MPC controller, we don't know how much an MPC will cost. Let's be very clear about that. But I hope at some point it will be cheaper to implement a rule-based controller than an MPC. So at that point, the return on investment is 0 years. It's directly. And I think we can get at that point, but we just need a lot more R&D to get there and to demonstrate that it actually works. So it really depends there a bit on what is the, indeed, what is the benchmark. And that makes me also wonder what is the main benefit. Is it energy cost savings? Perhaps not. And for whom? And is that then someone, is that someone who's paying the energy bills, for instance, which is not necessarily who is buying the MPC? Or is it perhaps just installation cost, which is cheaper? So I saw a few more hands being raised.
I'll pass it to you. Can I first remark? In the question or in the answer? Okay, then you're behind me. Just to say the return on investment. Of course, it's very broad. It can be very long, especially if a building is not really requiring a lot of cooling. So if you have a building with cooling demands, heating demands, and somehow balanced, could be by the architectural design, then you will see that it's far less than 15 years. Because then the other solution is to use a chiller and to throw the heat away. And then you come to 7-8 years. That's for some buildings, and then office buildings, which are in that situation. That's where we get if we do a calculation. If you look at heating-dominated buildings like elderly homes, it's very long to pay that back. Yeah? So, and that goes to 30 years. But there it's mainly that people stay alive in summer, in heavy summer conditions. That's worth something as well. And for the MPC, that's a no-brainer, because we have a very slow, complex concept then. And the MPC, even if they work a month on it, it will improve by far the performance of the concept. So, but in such a situation, it is it's a no-brainer, but they have to work a little more still.
Yeah, thank you. Short introduction. My name is Rick Kramer from Maastricht University. I think it's really important here to take into account also the effect of possibly enhanced productivity. Because if you only include the energy cost savings, then the payback time can be, of course, quite high. But for most companies, the energy cost is not an issue. It's about salary, because salary costs is more than 90% of the costs of a company, not energy. It's, I think, somewhere around 2 to 3%. So if you can enhance productivity by 2% by having a more advanced control, the payback time will be much shorter than if you only include the energy aspect. Yeah. Thank you.
Additionally to this, when we speak about payback time, of course, it's a comparison with a baseline scenario. If you take regulations into account, which oblige us to be nearly energy, which oblige the buildings to be nearly energy zero by 2020, then you get a completely different view. So you are obliged to invest in your building to have energy reduction, and then this system start to be much more attractive. Also take into account the gas price of your country. In Belgium, gas price is about a factor 4 cheaper than electricity. And the efficiency difference, let's say you have a COP of 5, which is quite good for your system, and you have a good gas boiler, then you have efficiency of 1. So there is a factor 5. Well, it's not that different. So, and your gas boiler uses gas, obviously, heat pump electricity. So you are still better off with your heat pump thanks to the higher COP, but the difference is not that big just because of the gas price. But take into account that gas price is probably going to increase in the future, and hopefully electricity price is going to lower, so that's also very important. And finally, finally, we are in this project, we are speaking about hybrid systems, and as Wim has said, to have a cost optimal system, you need to use it a lot for both heating and cooling. So if you have a heat pump with which runs for 1,000 to 2,000 full load hours, both for heating and cooling, there you can speed it off really quickly, and we speak even less than 5 years. So if you can design your system such that, for example, the heat pump will cover both cooling and heating load, and then the additional heating load that you may have is covered by a secondary system as a gas boiler, then you get your money back pretty fast. And the last added comment is that the business model of Johnson Control for the Stanford University campus, so here we focus really much into the control, is to have it less than 5 years. And that includes all the developments that they have to start from scratch for deploying their MPC and the algorithm and so on. So they have a team of 40 people working on this, which has been working for a couple of years, but as it was a 50 megawatt plan, they could get that payback time quite easily. So look also at the scale of your building and what's the savings of your system. Of course, the payback time is going to be higher for larger buildings, and the payback time is going to be also faster if you already have developed your software.
Yeah, just one final remark to this. It also depends on the country and conditions. We have one case study for KPIs, as Ellen reminded me. In Zurich, where the energy prices are really high, and I think you must use heat pumps right now, and you must build passive houses, your return of investment is like 0 because you have no other option. Well, maybe it's 1 year, maybe it's 2 years, but it's really quick. While in the Czech Republic, where the energy prices are low, you are obliged to build C-class buildings. We have the case of a public library in Dobříž here, and the return of investment is like never, because it's for the prices. But there are other motives why to build it. So we'll see if we'll have some more time at the end. This looks as a very interesting topic, but let's move on to the next topic, which is cloud versus local installation, and that's of Jiří.
Yeah, thank you. So this session is about practical aspects of MPC implementation, so it's not only about business models, but MPC has some specifics that are not typical, for example, for RBC controllers. So, and one specific topic is how to implement the optimization in practice. So basically, we have some topics, I have mentioned some points here. So there is the optimization task which has to be solved, and the optimization requires some special libraries which can solve the numerical optimization Then the second point is that MPC is a feedback controller, and as feedback controller, it needs some data that are fed into the controller, and it's really important to have high quality of this data, because if there is poor quality, it may lead to strange results. For example, if there is a fault of sensor that temperature is not 23 degrees, but there is some frozen value which is all the time same, and MPC takes this value and make decisions based on this wrong value, it's a wrong decision at the end. And normally the buildings are controlled using some heating curves or cooling curves, and these kind of data are not so important or are not used for directly in the control loop. So what I wanted to say is that basically there is a press on the high quality of the data. And the next thing, which is not very usual, is that the forecast is required. So we need a preview of future disturbances that influence the building states. And as we talked in the morning, one of the most dominant effects are by solar radiation, which needs to be forecasted. And the second thing is ambient temperature, which doesn't have so much impact, but the solar radiation is more important. We have identified basically two main options how to control the buildings using using MPC. One option is server option, that all the optimization is run on some server in this left part, and there is basically the model part, the visualization, historical data, some connection to the weather forecast services, and so on. And then there's the communication over Ethernet with the BMS system, which is here, which basically controls all the actuators and sends all the temperatures, humidities, and so on. So this is one option, which requires a reliable internet connection to the building, because the control actions are all the time sent through the internet, and also it requires higher security for this communication line. The other option is basically to implement everything in the building. It can be implemented on PC, which is located in the building, or it can be implemented on some better PLCs, programmable logic controllers, which have enough computational power, and which can, for example, be used for deploying of the mathematical libraries. So this is the second scheme, and here basically there's only communication of the weather forecasts from the internet to the PLC, which means that it's a more secure communication line. So these are basically two options, and this is basically what I wanted to say concerning the cloud versus local installation and the specifics of this implementation.
Thank you very much. Any questions for this topic? Yes.
Maybe Václav Preisner from Honeywell. Did you already do some evaluation, or did you evaluate it, these concepts, or could you comment whether in which cases is better to use cloud services, in which cases is better to do it locally? Thank you.
Yeah, this is a good question. We initially started with the cloud option because it's much faster to implement, and basically it's just a matter typically the buildings have SCADA systems, and if the SCADA system has some server version, then it's very easy to get the data, and then it's only a matter of server-to-server communication. But then it turned out that the investors typically want to have something in the building. So that's the case, and that's the reason why we nowadays put at least some some PLC with some part of communication to the building, and the sometimes complicated part and some part is in the server. So we have at this time calculation both in the building and in the cloud. So for example, we pre-calculate a weather forecast, or we pre-calculate some long-term optimization in the cloud, and the short-term optimization is in the building. And if there is no communication between the server and the building, the MPC in the building can do something for some time, for 1 or 2 days, over which the communication problem is solved.
Thank you. Very short question.
Green light. Okay. I would like actually to hear from the audience what's the case, like how does it look like in Prague, and if there are other nationalities also, how it works in their own country. In Belgium, at least the project that we are encountering, the BMS system often uses the internet network of the building, which means that if we get access to that because of our to send our set values from the cloud or from wherever, and we send it to the building, we are actually in contact with the local network, which is a serious security issue, because from there we could actually enter the building system. So at Bodens, we are trying now to define our metering files such that we oblige the installer and the building owner to have at least a switch between this network used by the BMS and the one of the building, and that solves a lot of security issues. I just wonder if it's similar problems that you encounter in other countries or not.
Yeah, maybe for Prague, I don't know if maybe Jan Cherokee can answer.
Yeah, at first I could say that in general in Czech Republic or in Poland there is the people in buildings are not so willing to implement cloud-based solution. So this is the bottom line that we are facing every day. So they need something that's installed in the building. And regarding the security issues, it's definitely the key point that will be solved over the next years, because in these days we see a lot of improperly protected networks and BMS systems. For example, we got a very dramatic example when we were just trying to connect to some system, and we found out that they had over the internet, public internet with default login, they do provide access to some water management system of the city. So such a cases could be found. And for example, we are working for banks, and they are very keen about the security, and they are doing this by means of their IT solution, where they provide you completely different network, and this is the best option where you cannot do anything wrong. And usually we end up with establishing our own solution, some GPS or Internet of Things connection that's used regardless of the network of the building owner, because of these arguments that you mentioned.
But you're the seller, you don't have network most of the time. Most of the time your installation is in the cellar where there is no network.
So thank you. we have the very last question to this topic from our chat room. In terms of investment and operational cost, which option is preferred? So what is cheaper, cloud or non-cloud? Very short.
From the operational costs point of view, the cheaper option is definitely the local installation, because the weather services we use are for free. We use NOAA, American Agency, or YR.NO. So these services are for free, and only if they change their API, then it's necessary to change it in the local controller.
Thank you. So we will move to another topic, which is forecast. It's whose topic is it?
So it's my last topic. And as I said, the second difference is the forecasts, which are not used in normal BMS control algorithms. So typically we have forecasts for these geotabs buildings 1 or 2 days, so that we see everything important on the prediction horizon. And the forecast of the disturbances is required for the complete horizon. Some part can be get from some statistical data, but something must be obtained from somehow. The sampling time of MPC is 5 to 60 minutes. It depends on the application, but the forecast should have the same sampling time. And what we would like to have, preferably, is to have update of the forecast data every sampling time, which is not typically the case. So what is the minimal set of quantities? As I said, it's weather data, and it's outdoor air temperature and solar radiation. For example, the weather services works like that there is some strong computer that calculates or takes all the measurements from the airs and calculates something, some update, and NOAA makes updates every 3 hours, but based on data which are 1 day old, so it's not always very updated. And I think YR.NO is very similar, and basically all weather providers have similar structure. So basically the only way how to get really good quality or very updated data is to use local weather station, which can provide some data. But the weather station costs something, and so on. From our experience, the outdoor air temperature, if there's some mismatch in the forecast, it has low impact on the controller performance. But the solar radiation, this is quite important. And if the building is compact and the windows are small or very good G value or good blinds, then it doesn't have so much impact. But for fully glass buildings, this is quite important. And it's also important to take into account the control algorithm of the blinds. The MPC should know how the blinds are controlled. This is a big problem. And what is also important, and it wasn't mentioned in the morning or stressed in the morning, is the occupancy forecast. So the occupancy can provide also, or can bring big changes to the temperatures in the rooms. So that's the reason why these geotabs buildings should also be so like a lot of square meters per person. And the occupancy forecast can be also an issue. It's not issue for the buildings where there are fixed schedules, like schools or buildings with fixed regime. But for other buildings where there's like the people can come arbitrarily, it's very difficult, and the only way is to have some statistical model. typically some autoregressive models or machine learning models, basically. So, and there we see a problem that the BMS systems are typically independent of the systems for the occupation. These two systems are not connected, and the BMS system doesn't know how many people is in the building, and basically sometimes it's even problem to get the data from the occupancy systems. So that's all from my side.
Thank you very much. Any questions?
Is it necessary always to know the occupancy in the MPC? Can't you use CO2 and temperature and connect that to estimate? Or
yeah, from measurements of CO2 and temperature, we can create a statistical or machine learning model of the occupancy. But we need the forecast. We are at some time. We are at 8 o'clock in the morning at school, or in some office building. There's CO2 500 ppm, but we know that in 2 hours there will be a lot of people, and who will produce a lot of CO2, and also internal gains. So it's important. Okay, we can use this CO2 data, historical CO2 data, to create some model, and we will use this model to forecast the future occupancy. But it has really huge impact on the temperatures, so it's important to use it.
Thank you. Any other questions? No. Okay. So, thank you, Jiri. And next. So next is Philip.
Okay. So next topic is about sensors. What did I write down here? I made the slides a bit different. I'm actually asking some questions myself, so I'll go through these quickly. And if people think they have something to mention about this, feel free to pick in afterwards. So what sensors are actually being used commercially right now? I have some experience where in the building that I modeled, and most of these are available. So that's a very nice case, of course, where you can use all these sensors essentially to calibrate your model and to get feedback. But I'd be interested to find out what are typically being used, and in the foreseeable future, perhaps what will be added. And then I'm mostly interested in temperature and flow rate and CO2, essentially. Then these sensors, what quality can we typically expect? And again, also, do we see this changing in the future? If there is sensor drift, for instance, I've noticed is that where 2 sensors should essentially give the same value, you can have an offset of like 0.8 Kelvin, which is quite a lot. Ideally, we don't have this. On the other hand, if we know that we can expect this, we can take this into account. But yeah, I'm sort of wondering, like, is this, for instance, also that this is an issue that we don't just have with model predictive control. Rule-based control also uses these sensor values. Also, so if there is a sensor stuck, weird things will happen. And perhaps after a few years of time, someone will notice, like, hey, this is behaving funny. And actually then with MPC, I think we're even better off, because if we have like a detailed model where we expect some reaction between a control signal and a sensor, and we don't see this, it should be fairly easy to spot that and flag an alert. And then in terms of business case, once we do have these sensors, it would be interesting, of course, to think about what can we use these sensors for other than just control. One thing that I just explained is fault detection and diagnosis, so that's acronym FDD. And perhaps people are thinking of other examples where these sensors could be used, for instance, just for plotting on an app or things like that. So those are the bit the questions from my side. If someone wants to pick in here.
More questions.
I actually have a comment and then a question about the uncertainty about the sensors. I think temperature sensors, there is a drift, but it's relatively okay. I mean, it's within 1 Kelvin more or less. CO2 sensors, the drift is huge. It can be double the value, triple the value of what you started from. So that's a much bigger problem, I think, if you're trying to incorporate those VOC sensors. It's even an order of magnitude bigger than that. So it really depends on the type of sensor you're using. And I had a comment, what could be additional benefits? It's more like a question on how to deal with your objective function. Do you see a possibility where users can dynamically influence the objective function of your MPC during the occupancy?
Yeah, so you can hear me, right? Okay. So can users influence? I think the idea is that right now, right now with rule-based control, you have a set point for a thermostat. I think with rule-based control, you have the same thing. Sorry, with MPC, you'll have the same thing. So we indeed would have some sort of feedback, and I think I have a slide about that afterwards. Yeah. And I was actually wondering myself, with the CO2 drift, it's sort of constant, right? It's not like... Yeah. Yeah, okay. Any further comments?
For this, maybe for the CO2 sensors, we had similar problem in one project, and we solved it by using actually 2 CO2 sensors, because the CO2 sensors drifts according to its own time and not like absolute time. So if you have 2 CO2 sensors next to each other and you switch one just once in a month, it doesn't drift. So you can calibrate the second one with the first one. It's like more expensive, but what's more expensive, the sensor or the calibration? It's a question.
Yeah,
so
just a practical comment as well, that it's a lot of CO2 to implement, and the location of them is crucial, right? So what Yellow was saying, and most of the time in buildings you'll have it in the exhaust, where it's already mixed. I mean, you don't get the reality. You need really to have them between, like, in the breathing zone, the person at the desk, or if you measure that already in the exhaust there, that's not going to be accurate. That's our experience, and in normal buildings, you will not put you put CO2 sensors in densely occupied room, in meeting rooms, to control the ventilation accurately, but the rest of the room you probably won't have that as a typical spec in your building, I would say.
okay, thanks for the comment. We can go for the next topic, which is modeling.
Okay, so this is me again. See. So we've shown this before. We have to make a building model at some point, one-to-one mapping. It's a lot of fun. So the mapping, that's one part, so going from here to here. But then you have these component models, and essentially they still have a lot of parameters. Something I want to discuss here is a bit what type of complexity that remains there is still acceptable. And what we're a bit on the bridge now between entering actual properties of models and types and manufacturers of models. So the difference is, for instance, if you have a valve, then in case of a property, you would enter a KV value. And if you have a type, then you could just say, okay, it's this manufacturer and that valve type and that size. And of course, the second case would be easier, but yeah, it's a lot of work to get all the properties, and perhaps they change over time. So I'm not really sure how to proceed there. And the same case can be made, of course, for instance, a heat pump. Do you have a COP curve, or you just have the manufacturer type and the manufacturer and type? And essentially what this boils down to is how easy it is to make these models. And at the very base, you have to, very complicated way of doing it, where we started out with our research many years ago, where you essentially have to manually code all equations. And then there were simplified approaches where essentially you try to fit some models by merging multiple components into one to keep the computation time down. And those were typically these more, for instance, gray box models I would position there. And then we're essentially on the bridge here so this one-to-one mapping of components with properties and having types. So we have some components for which you have to enter the properties, and for some components you have to enter types. And in a foreseeable future, hopefully we could even automate it more based on building information modeling. So that's something I would like to mention also, that this isn't the end goal yet. Building information modeling is becoming more and more integrated into workflows of architects and engineering offices. And ideally, at some point, we would get at this last stage where you can just grab these building information schematics. It contains all the connections, components, and their types, and we automatically parse that into a controller. And then, it becomes a real no-brainer, of course. But also, for instance, if you maintain the system, you replace a pump, you just update the BIM model, you regenerate the code, and you get a new controller. So that's the ideal way, and then it doesn't cost anything anymore to make these controllers, where now you need to be sort of an expert. And then there is still a solution in between, a bit of a hybrid solution where some information is available in BIM, but not everything is supported yet, or people don't put it into the schematics and things like that, where we could parse a BIM model, but you have to complete it essentially for some missing types or parameters that are not yet in the schematic. And now my question is a bit in terms of this workflow. What do people think in their experience is realistic? How much can it take in terms of time commitment to make such a controller? What kind of expertise can we expect from people? I suppose we don't want people to have a PhD in optimization, but what general knowledge can we expect from people? What knowledge is the current background of typical people that make controllers and things like that? So these are a bit questions that I am wondering, and also with respect to some issues that perhaps are part of the current scope of existing controllers, but that we're not considering yet. For instance, fire safety. I don't know a whole lot about that, but as far as I understand, if there's a fire, the fans go on and everything is evacuated. And these kind of things probably then have to be integrated into MPC also at some point. And those are things that perhaps we're missing something here, and it will be also nice to get some feedback on that. Or comments.
So I know that for the implementation of what you are working towards, the BIM has all the information basically. That in the US they are actively working on making data structures and templates to describe each of these components, so that manufacturers can deliver this information. Are you aware of similar things going on here in Europe? Because I think that's one of the necessary steps to get to this Valhalla that you're working towards.
Was that within the ASHRAE sort of thing that was going on? Is that, so I'm not aware of any initiatives in that sense in Europe, but I'm not aware of a whole lot in that sense, to be honest. But it's perhaps something we at some point have to take initiative. And then I'm thinking at what point should we do this? Probably shouldn't wait too long with it. Damien, if you have a comment.
Just to answer Jelle's question, I'm aware of one thing is So when we speak about BIM, often we also think about a really prominent software called Revit, where you can draw your system in 3D, both your HVAC system and your building. And Revit uses family for the different components, and the information about the component is so included in the family. And I know that in the Netherlands, they have had an initiative or 14 different companies coming up with an open source library of families for HVAC system. So this is then uniform for Holland, in the hope that they are all using it. And in Belgium, there is a BIM company called TechBIM, who is also working on with the different engineering offices of Belgium to try to get an open source BIM library. Again, that's something where we have to look at which type of information are available in it and which not. But keep in mind as well that there is different type of BIMs. There is the BIM where you describe that you have a given component somewhere, but it's not related to a type of manufacturer. And that there is the more advanced BIM where there is all the manufacturing data into it. And I think that's further away in the time. So I don't expect this in the next year.
Sorry, going back to the
Thank you.
Sorry, going back to the previous comment. Isn't that exactly what IPSA Project One is doing? The sort of thing you were talking about, which is coordinated by Michael Vetter at Berkeley, but also Christoph van Schriek at Aachen. So I think probably there is European activity in that area. Sorry, I'm not speaking in the microphone correctly. So that's my understanding.
Yeah, we're indeed active in this project. I'm not active myself in the BIM part, but the way I understand it, we're indeed working on tools related to BIM and integration with simulation tools like Modelica. So it's a translation step from BIM, for instance, to Modelica that we're interested in. But as far as I know, there is no initiative to make really this collection of models and to standardize the description within that project. Am I correct? Yeah, so we're not entirely sure on that, but that's my understanding.
Yeah, maybe we should proceed to the next topic. So, advantages of MPC.
Yeah, so we already discussed it a bit in the part about business models, and I touched upon it earlier already. But for me, there are quite some advantages of MPC, and I'm going to quickly go through them. So one of them is environmental impact. So we can save energy and hence also CO2 emissions. At this point, we have often fixed cost functions, but in the foreseeable future, if we have smart meters with variable CO2 emissions and things like that, we could also take that into account into an MPC, and that further reduces both the energy use, cost, and CO2 emissions. That also is linked, of course, to CSR, corporate social responsibility, where often companies try to have a green image, and this could be one way of doing that. Our own university is really going for, and our city also in Leuven, they're all going for green initiatives, and this could be one way of doing that. Thermal comfort and increased productivity has been mentioned. For me, a big important one is also the easy and systematic implementation of controllers in buildings. So right now, often you need to think a bit about what does a building look like, how are we going to control it, what parameters do we need to set. It's an iterative process because you implement it, you see you've made an error. Often there's a commissioning process of multiple years, and I think this can be also really simplified using MPC when it's robustly implemented. This calibration of parameters of rule-based control often happens at a certain point in time. If the building use changes, then this calibration may not be valid anymore. Essentially, internal heat gains, for instance, offset the heating demand of a building, and if that internal heat gain changes, then all your parameters need to be recalibrated. So rule-based control is often not robust against changed use of a building, and that's something MPC could also bring benefits. There are complementary, I call it products, but let's call it services. If you have a model of a building, you can also use the same model for fault detection and diagnosis, also for just forecasting the temperatures within a building as information for the building occupants and things like that. Renewable energy sources are increasingly present in buildings, but they're also not that easy to integrate. Depends what type, if it's thermal or electric. If it's electric, also time of use pricing can become important again. Things like self-consumption have a lot of potential there also. Reduced maintenance and configuration, I think I mentioned that. At some point it may actually be somehow relevant with building codes also, that you have to be compliant with some energy efficiency, and that can be some way of getting it through improved control. And then again, yeah, CSR and this marketing and image is a bit related, of course. So there are really many, I think, things that can be taken into account when quantifying the benefits that MPC can bring to the industry. And the question that I have a bit at this point, which is not entirely clear to me, is which is the most important one. And that's not just in terms of what is the most important one, but it's also which one is important for the people who are actually going to choose whether we use MPC or RPC, so rule-based control. Because essentially, if you can save 50% energy, but that's for the actual building owner, and the building owner doesn't buy MPC, the building owner tells his contractor to do something with the building, then, I mean, the incentives are not that much aligned. So, in my opinion, I think at this point, what is a very strong case is a simplified way of implementing a controller for a building and more robust implementation. And it would be good to get some more insights on that if someone has another opinion or if there are questions.
I got just a short comment. I do miss one of the important points here, that since the energy market is changing towards more usage of renewables, and you have more investments into distribution, so also the energy bills are made such as that you have pay more for distribution in these days, and it will be even more in future. And MPC has one of the nice features that it could prevent your these peaks and peak shaving in general, and this could be in future more important in terms of money, that it could save you money for distribution, not just for energy consumption.
So that includes demand response, I suppose, yeah, and things like that, yeah, and other, for instance, frequency control and things, and we're really pushing it, but yeah, that's also something indeed that could be important there. Any further comments? So if I can repeat the question, so how many buildings are getting involved with the demand response? That was your question towards.
Yeah, actually, one of them is the Liebesnitze building, where we will be today afternoon. And for example, we implemented MPC in the building just a few meters away from here. It's also a Tubbs building, old building from 60s of the last century. And here we implemented just because of energy savings, like 8 years ago. But 2 years ago, we were facing some changes in the distribution tariffs, and there was some significant amount of money paid due to some maximum of heat power, and it was very easy for us to change city or make use of MPC for this purpose. And yeah, we were quite surprised by the outcome, that it preheated the buildings like one and a half day before it was actually needed. And this was something that a human operator would not be able to schedule.
There's, here in the Czech Republic, there's we know the Nano Energies company. They do this on 15 minutes basis, and I think they have how much is their how large is their share of market?
Well, it's in the Czech Republic we have like 30 megawatts, which are the error, the system error in the electricity. So basically we need some flexibility for 30 to 60 megawatts. which should be included in this demand response program. My rough estimate is that we need 1,000 hybrid geotubs buildings for that, or we need 1,000 battery storages, which is, from my point of view, most probable in the near future. So, yeah, there is the demand response potential in the hybrid geotubs buildings, and maybe you will see it in the afternoon in the Liebesinte school. But I see bigger potential in the for the demand response in the better integration of the controls of these hybrid energy systems, including batteries.
Thank you. So we may go to the, I think it's the last topic.
I think so too. So one more thing. So what we've been discussing so far is control of thermal systems in buildings. Essentially what we're talking about there is system integration. You've got multiple components from different manufacturers. Somehow they have to be coordinated to the building envelope, which has a lot of people running around and doing stuff. So it's system integration, and there will always be more systems that can be integrated, and that's a bit along the lines of what I was thinking, which ones are interesting to integrate further. Wait a minute, are you pushing the button? So here's a list of things that I came up with, so similar, I'll go through them quickly. So one of the things is we already have a building model which contains walls in a building and the type of glazing and the location of windows and shading. So that would allow us in theory to compute how much light enters a building and thus what the additional lighting load is, and take this into account somehow, and also schedule lighting, for instance, or do adaptive lighting and things like that. You could, for instance, take into account the effect of shading that can be controlled by MPC also, on the effect on daylighting and on the energy balance, and use this to get a better overall solution. Another thing is natural ventilation, which can also be interpreted as an HVAC system, of course, but so far we never integrated it. Occupancy schedules could be grabbed from calendars, etc., but then privacy issue could pop up, of course. So as I mentioned, the blinds, so external shadings of windows, etc., can directly be controlled to also affect the energy balance. In the future, it would be very interesting if there were electrochromic glazing, so that's glazing where you can put an electric potential across the glazing, and then that affects how much light can enter the building. And in a particular case, you may even have one of these films on both the inside and outside, and then you can even control whether the light is emitted on the inside of the building or at the outside. So you can both affect the heat balance then and the lighting again. And these are things that could be very well integrated, but yeah, so far the product doesn't exist yet commercially, as far as I know, but it's something that could also be interesting. So PV panels, I mentioned it already, with time of use pricing can be very interesting. Domestic hot water production, district heating is something that could also be used, of course, again with the time-dependent pricing, if that's the case. In the US, it's more often the case that there is a capacity limitation on the peak electrical power that you can use. In Belgium, it's not the case, perhaps here also, I don't know. But that's something that can be certainly taken into account to limit the capacity charge of your electric connection, and things like fire safety could also be integrated. Again, so if there are comments on this or suggestions, questions, this is the time.
Thank you. My first suggestion, fault-tolerant control. Because you've spoken about faults already, but I think the reality is that even when people know there are faults in a building, they tend not to be repaired. So can I suggest fault-tolerant control as a something?
Yeah, so fault-tolerant control, you mean if there is a fault that you deal with it? Yeah, so that's indeed, I should go down. So that's indeed an option if you notice that, for instance, a valve is stuck that you identify this, and you then consider that the valve cannot be controlled anymore, you fix the position into the model, and you work around that. So that's something that would indeed should be possible with this white box modeling approach, and then you work around the problem until it's fixed, or you don't fix it.
Actually, it's a very valuable point that current control system already generate alarms which are happily ignored for many years until the temperature is just too unbearable, and then we look at it. But with MPC, if you have a model, you can actually transform that into a cost. And if you send an email saying, what's the expected cost of the problem, I think you will get more response. And that could be a new functionality of MPC.
Yeah, I was thinking of that also while you were grabbing the microphone. So indeed, we could compute what the cost of this error is, and then it may also just not be necessary to fix it, of course, until a scheduled maintenance of the building.
So maybe we can skip to the last topic.
I think this was the last topic.
Interaction with MPC.
Oh yeah, there's another one. Yeah, I've been creative yesterday evening. I added more. So this is fairly short. So what I was wondering about right now with rule-based control, people either end users don't directly interact, or they can often interact by offsetting a temperature set point of a thermostat. But that's pretty much it. And MPC offers a lot more options, I think, which could be interesting, but then the question is also, do we want to expose all of those? One of the things is, again, to influence temperature limits, and you could, for instance, allow the users to adjust the electricity cost, if it's a fixed electricity cost, either just because it has changed, or to somehow affect the MPC algorithm in a different way. If somehow you feel like I'm in a very environmental mood, so I don't want to use gas as much, then you can yourself reduce the electricity price, and the MPC will correspondingly use more electricity rather than gas. And that's one option of things that we could do. One other way of interacting with MPC is to fix certain optimization variables. I think that's also related a bit to the comment about fault-tolerant control. If you notice that something is wrong, then you can manually fix a certain optimization variable and have the MPC work around that and deal with it. And a nice functionality that I think you can do it when you have these models is to actually extract certain variables from the model. So we forecast a lot of temperatures forward in time, for instance, the zone temperature. Same thing with costs, and I think it can be quite instructive for people if you have like some interface hanging in the building that shows how the building will behave the coming days, or what has happened, and things like that to get the people more involved with what's going on. So if people have other ideas here, again, feel free to comment.
Yeah, about user interaction, one of the main results from research in that area is that users want to feel empowered to act if they think something is not to their desire. And I think one of the main, the negative would be if implementing MPC implies that you take away this possibility. I think the positive could be that the MPC could provide feedback. Okay, you're now considering taking this action. We calculate that the cost of this action will be X. Do you really want to do it, yes or no? That could be a really interesting additional value brought by the MPC without taking away the possibility of the user to actually do this.
I think that in most big buildings, users have no interaction with their BMS.
And the question is then also becomes, how should they interact? Because perhaps multiple people have different opinions about temperature and things like that. Okay. I think that's it for the questions.
So thank you very much for this session, for your contribution. I think it was very interesting. Thank you, Philip and Jiří, for your ideas. So now we will have the lunch, but before the lunch, I will try to very shortly introduce the tunnel. May I? Yes. So. Yes, the Blanca Tunnel Complex. So we will, on our way to Líbeznice, we will go through the tunnel which is called Blanca. My wife is also Blanca, so I especially like it. But it was also topic of my PhD, and it's the topic of PhD of Jan Schulz. And this is actually the project where we started with MPC. The Blanca tunnel is a long tunnel. It has about 6 kilometers, 5.7 or so. It has 2 tunnel junctions, and we are here in this building. So we will meet at the Diplomat Hotel. We'll go through here and enter the tunnel, and go here down the hill beneath the Vltava River. Hopefully not through the Vltava River, and leave the tunnel here in Troja. It's one of the largest tunnel complexes in Europe, and for the ventilation system of the Blanca tunnel, it was not possible to use traditional controllers, so we turned to MPC. Yes, it has mixed type of ventilation, so you will see jet fans that are hanging beneath the ceiling of the tunnel, and big, really huge ventilation centrals which are hidden, but we can show you where the air is injected into the tunnel and where it's sucked out of the tunnel. It has also a fire ventilation for emergency purposes. And our task was to minimize the energy with respect to air quality requirements, but it was really more of really making it work, because the original company was trying to control it with PID controllers. They were doing it in Excel, Microsoft Excel, and after like 3 years of trying, they said, no, we will need someone who will do it properly in MATLAB and with all the fancy stuff that we know how to do. The results were quite impressive. Actually, the tunnel has how many, like 1,600 equations, differential equations that describe the tunnel. And there are about 80, 90 control sections. So in terms of buildings, it's like a building with 90 zones. And surprisingly thanks to Jan Schulz, who made actually 2 models, one for control, one for validation with different strategies. It ran like on the first switch, so when it was turned on, it was yeah, but the fire ventilation, it was the fire ventilation was it was like the biggest concern in tunnel is a fire ventilation. So in the case of fire, you need to create a safe environment within the tunnel. So the fire ventilation was like really smooth. Okay, for the operational ventilation, it was a little bit more complicated, but it's working, it's running there, and the project started in 2000. Yeah, for you, but for me it started in 2002, 2003, which gives you an impression on how complicated this project was. It was a big political issue here in Prague. It cost about twice as much as it should have costed. So yeah. So, and I finished my PhD at 2007, but in 2003 the project started because they thought that in 2004 they will begin the construction. So, and then it went on, and it was a typical project of MPC, I think, because I came up with an MPC strategy which was not some super MPC, let's say. And they said that it's too complicated, so they started trying to tune the PID controllers, which was not working. And in 2015 they came again and they asked us to to do it. So Jan started working on it and made a NPC that is actually working. So that's just for fun, not really related to the buildings, but yeah. It was like 1.5 billion euros, so quite expensive. There's a question. Perfect. Well, you don't really need a prediction there, actually, but you need a MIMO controller, multiple input, multiple output control. Otherwise, you cannot tune. If you have PID controllers, you would end up with a matrix of 90 times 90 controllers, maybe in 90 dimensions. So it's almost impossible to tune. And the prediction is especially for the energy peaks. So if you expect higher traffic and you know that you will exceed your energy, your reserved power, you can pre-ventilate. But the dynamics are quite fast in the tunnel. So for operational ventilation, you do not really need the prediction. For fire ventilation, where you operate on much shorter scales, then it's handy to have some predictions, some dynamic predictions. But the main driver was that we have a multi-dimensional controller. Okay, so now we will have a lunch upstairs. You can leave your stuff here. It will be securely guarded. The doors cannot be opened, so. For those who know the way, we will meet either at 3 o'clock in front of the Diplomat Hotel or 10 minutes to 3 here in this room.